Chapter 3. Basic Concepts of Probability. Sample spaces, events, and their probabilities. 1. Sample space. The sample space is a set of all possible outcomes in a probability experiment. It includes everything that could happen. For example, when tossing a coin, the possible outcomes are heads or tails. When rolling a six-sided die, the possible outcomes are the numbers 1 to 6. 2. Events. An event is a specific outcome or a set of outcomes from the sample space. It represents what we are interested in. For example, in rolling a die, an event could be getting an even number, which includes the numbers 2, 4, and 6. Another event could be rolling over a number greater than 4, which includes 5 and 6. 3. Probability of an event. Probability measures the likelihood of an event happening. It is found by dividing the number of favorable outcomes by the total number of outcomes in the sample space. For example, when rolling a die, the probability of getting a 3 is 1 out of 6 because there is only one way to roll a 3, but 6 possible outcomes in total. If an event is certain to happen, its probability is 1. If an event is impossible, its probability is 0. 4. Types of events. A certain event always happens, such as rolling a number between 1 and 6 on a six-sided die. An impossible event can never happen, such as rolling a 7 on a standard die. Mutually exclusive events are events that cannot happen at the same time, like rolling both a 3 and a 5 in one roll. Independent events do not affect each other, such as flipping two separate coins. Complementary events are pairs where one must happen if the other does not. For example, if the probability of rain today is 30%, the probability of no rain is 70%. Complements, intersections, and unions in probability. 1. Complement of an event. The complement of an event includes all the outcomes that do not belong to the event. If an event has a certain probability of occurring, the probability of its complement is found by subtracting from 1. For example, if the probability of drawing a red card from a deck of cards is 1/2, then the probability of not drawing a red card is also 1/2. If the probability of it raining today is 30%, then the probability of it not raining is 70%. 2. Intersection of events. The intersection of two events includes only the outcomes that belong to both events at the same time. It represents situations where both conditions are met. For example, when rolling a die, suppose one event is rolling an even number and another event is rolling a number greater than 3. The numbers that satisfy both conditions are 4 and 6, so the intersection of these two events includes only these two numbers. 3. Union of events. The union of two events includes all outcomes that belong to at least one of the events. This means that an outcome is counted if it belongs to either event or both. For example, when rolling a die, if one event is rolling an even number and another event is rolling a number greater than 3, then the union of these events includes all numbers that are either even, greater than 3, or both. This means the numbers 2, 4, 5, and 6 are included. 4. Probability of unions and intersections. To find the probability of a union of two events, you add the probabilities of both events and subtract the probability of their intersection. This prevents double counting outcomes that belong to both events. For example, if the probability of rolling an even number is 1/2, and the probability of rolling a number greater than 3 is also 1/2, but the probability of rolling a number that is both even and greater than 3 is 1/3, then the probability of rolling a number that is either even or greater than 3 is found by adding the first two probabilities and subtracting the third. Conditional probability and independent events. 1. Conditional probability. Conditional probability refers to the probability of an event occurring given that another event has already happened. This means that the likelihood of one event depends on the occurrence of another. For example, in a deck of playing cards, the probability of drawing a king is normally 4 out of 52. However, if one king has already been drawn and is not replaced, the probability of drawing another king changes because there are now only 3 kings left in a deck of 51 remaining cards. This concept is useful in real-life situations, such as predicting the chance of rain given that it is cloudy or calculating the likelihood of a student passing an exam given that they studied. 2. Independent events. Two events are independent if the occurrence of one event does not affect the probability of the other event happening. For example, flipping a coin twice is an independent event because the result of the first flip does not influence the second flip. Similarly, rolling a die and flipping a coin are independent because the outcome of rolling the die does not affect whether the coin lands on heads or tails. For independent events, the probability of both events happening together is found by multiplying their individual probabilities. This is because knowing one event happened does not change the probability of the other. 3. Dependent events. If two events are not independent, they are considered dependent, meaning that the outcome of one event affects the likelihood of the other occurring. For example, when drawing two cards from a deck without replacement, the probability of drawing a second king depends on whether the first card was a king. If the first card was a king, there are fewer kings left in the deck, changing the probability for the second draw. Another example is choosing students for a team. If one student is selected, the total number of available students decreases, which affects the probability of selecting another specific student. Definition of empirical, observed, probability. Simple explanation. Empirical probability is when we find the chance of something happening by actually doing an experiment and counting how often it happens. Instead of guessing or using math formulas, we observe real results. Example: imagine you flip a coin 100 times and get heads 55 times. The empirical probability of getting heads is 55 out of 100, or 55%. If you keep flipping the coin more times, the probability might change a little, but over many tries, it gets closer to the true chance, which is 50% for a fair coin. Empirical probability is based on real-life observations, not just what we expect to happen. The more times we test something, the more accurate the probability becomes. The empirical probability of event A, denoted as P'(A), is found by dividing the number of times event A occurs by the total number of trials conducted in the experiment. Theoretical probability is the expected chance of an event happening, based on what is known or assumed about the situation. It is determined by considering all the possible outcomes and figuring out how many of those outcomes favor the event you're interested in. For example, if you're rolling a fair die, the theoretical probability of rolling a 3 is based on the fact that there are 6 possible outcomes, and only one of those is a 3. So, the chance of rolling a 3 is 1 out of 6. This type of probability doesn't require any actual experiments. It's calculated using logic and reasoning.